Okay, this is example 4. So problem solving using similar triangles. And this is the figure that you're given in the book. And the problem states a man who is 6 feet tall, right? Here's the man 6 feet tall, is standing 10 feet from the base of a lamppost. So here's just 10 feet from the lamppost. The man's shadow, right? Here's the shadow, is a length of 4 feet. So how tall is the lamppost? So we're looking for how tall, or what's the distance, right, from here to here. And we can call that X if you want to call that H for height. It doesn't matter. So what I want you to notice here is, let's see, maybe in, okay, let's do blue. Well, obviously, okay, we see the big triangle, right? So here's one big triangle, and the similar triangle is going to be this, well, this right here. Okay, so there's one triangle, right? And then of course we have the big one. So I'm gonna go ahead and just minimize that, because all we really need is we have the big triangle and we have the smaller triangle. And that one, well, it's obviously smaller, but it looks, it's bigger than than the one in the picture, but we get the idea, hopefully. So here they're similar triangles. Well, why are they similar triangles? Sorry, that's the T is ready, but okay. So I know that they're similar triangles because this angle, right, has the same measure of this angle, right? This guy, whatever this angle is, I mean, from the ground to the lamppost, or the ground to the height of the man, this is still the same angle. So we know these are corresponding angles. And also these are corresponding angles, right? These are 90 degrees, right? Assuming the lamppost, right, is exactly 90 degrees, right? It's 90 degrees with the ground. So we have some lengths here, and let's just go ahead and put them in. So here we have 6 feet for the man and 4 feet. And let's see, we have X. And remember, this base, right, represents all of this. So this is 10 plus 4, so I know that this is 14. Again, this triangle, I mean, if you want to, this should be a little bit smaller, but here we can construct a proportion, which again we've worked with before. So we can say, again, it doesn't matter. I'm just going to go this side to this. So this side corresponds to this side, right? So I'm going to go from big to small. If you want to go from small to big, the ratios, it's not going to matter. So I'm just going to go big to small. So I'm going to say X to 6. And again, I started with the big triangle, so I've got to start with the big triangle again. So here we have 14 to 4, right? So this side corresponds to this side. And we have 14 to 4. And we can cross multiply, that's fine, which we will actually. But I want to reduce, right? We can reduce, right? We can divide this by 2 to make it a little bit easier. The book doesn't, but I mean, if you can reduce, why not? And let's see. Let's bring this. Okay, so I'm continuing here. So if we cross multiply, we get 2x equals 42, and half of 42 is 21. So the lamppost is 21 feet. So we're using similar triangles again because we have corresponding angles, right? These guys are the same measure, these guys are the same measure, and then we set up the proportion, right, using the corresponding sides.